Electric field intensity. Electric field intensity at a point in space is equal to the force per unit charge exerted on an extremely small positive test charge placed at that point. The meaning of this sentence is, when I have a charge, as I said, when I have a charge, then it is going to produce electric field. Okay, and the space around this charge is known as the electric field. And now when I bring a small positive test charge, now this is a test charge. Okay, as I said, a test charge is something that has a very low magnitude. Okay, now this is a small positive test charge which I am trying to bring at one particular distance from this charge. Okay, I bring this test charge from somewhere else and I place it here. Okay, such that this particular charge is going to produce some amount of field. That is, it is going to fill up this region of space by electric field. Now when you bring a test charge at a close proximity of this electric field, it is going to experience a force. Okay, now force per unit charge is going to be experienced by this test charge. Okay, so this region out here, when you bring it closer, okay, it's like how much of the electric field is affecting this test charge, such that this test charge is getting pushed away. That is your intensity of the electric field. Okay, also known as electric field intensity. How much is the force being exerted on this test charge by this particular charge that is producing the electric field on this region of space? This is electric field intensity. Imagine it to be something like this. This is my charge Q plus Q, and this is my test charge Q naught. Now when it is somewhere here, okay, suppose if this charge is producing an electric field within this region of space. Okay, this region of space is being filled up by the electric field produced by this particular charge. Now when I bring this particular charge from this point to a little closer to this one, just like in the case of magnet, where they can feel the force of repulsion or attraction. Now this is going to feel some kind of force acting upon it. Okay, since this is a positive test charge that we are taking, hence it is going to feel an act of repulsion. Okay, now as I bring this closer, what is happening? More is the strength increasing of this electric field to push this test charge away. Okay, it's like the intensity of the electric field is increasing. Hence this is known as electric field intensity. The force per unit charge acting upon this particular test charge, okay, by this electric field. Okay, this is your electric field intensity. Electric field can be introduced as force per unit charge. Force per unit charge. Okay, and you can write this as force is equal to QE. Okay, you should remember that electric field is a vector quantity, whereas charges are not vector, they are scalar. But electric field, that is the field being produced by the charges, is a vector quantity because they have a direction. Okay, and also its unit is Newton per coulomb. Force by charge, this is Newton, this is coulomb. So Newton per coulomb is the SI unit of electric field. You can also write the SI unit of electric field in terms of voltage per meter. Okay, voltage per meter. So this is your electric field intensity. Okay, where the charge is going to experience some kind of force, okay, which is the force per unit charge acting upon that particular test charge.